station.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready.
Canadian Space Agency, this is Mission Control Houston. Please call Station for a voice check.
Station, this is Charlottetown, Prince Edward Island. David, it's Jeremy. How do you read us?
Jeremy, I have you loud and clear. How me?
Yeah, I've got you loud and clear, David. I didn't tell them down here that there's a pretty big delay when we send that signal to space. So when you ask your questions, you just got to be patient. David will hear you a couple seconds after you send it. So it's great to see you floating in space, my good friend. You're looking great, having a great mission. You can't see us here, but I'll tell you, I'm in a gym. It's my first visit to Prince Edward Island. We got a room full of some excited young Canadians. Great energy in this room. They're really excited to speak with you today. And I'm standing here with Ifra and Morgan, and I understood that you heard a little bit about them already and maybe had a question or two for them.
Thank you, Jeremy. Well, everybody, welcome to Space Station. And yes, I'm excited that you guys have been studying more about our beautiful planet. And I was wondering, what did you learn about what we're looking at all those photos and reading all those notes on the website? Anything special?
The main thing I learned while going on exploring Earth is that the spread of deserts and sand dunes is a major threat to nearby farms because it stops crops from growing.
Very true. The entire kind of balance of life on Earth depends on each other. It's a big balancing act. And is anything particularly surprising or shocking to you in the photos?
Yeah, I saw a photo of Montreal, Quebec, Ottawa, and Toronto at night. And the lights in Montreal were a lot brighter than Toronto. And that really surprised me because Toronto is a very big city with lots of lights. And then I read the caption, and I found out that it only looked that way because of the angle and distance of the photo. And it really surprised me that it had such a big impact on how it looked.
Yeah, it's interesting, eh? And it goes to show that the Earth is round. So even between a distance like between Montreal and Toronto, we don't see it at the same angle because we're looking at different points on a sphere. Yeah, it's amazing the perspective you get of our beautiful planet from orbit.
So, David, you can't see, but Morgan's here too, and he had an answer to that question. Yeah, just both of them. Go ahead.
So the main thing that I learned from the Exploring Earth website was the global warming. I knew that global warming was a problem, but I didn't really kind of grasp the severity of it, and it's just kind of, it's shocking how, like, this is a big problem and it's not going away, and how it's just getting a lot worse, and it's a genuine thing you can feel, like, Earth getting warm.
Yeah. You're right. I had the same feeling, how it's obvious when you look at it from here that our beautiful planet is fragile and we should be responsible for it and take actions. And in a way, I think it's a good wake-up call for everybody.
And the picture that shocked me the most was the ozone layer, because I never really knew that you could see it. And it was also it was kind of eye-opening to see that that's the only thing that's keeping oxygen inside and keeping everyone alive, and the way that we breathe and everything we rely on and live on is just held in by that, and kind of eye-opening to see the way that we actually treat it and the way that we just kind of pollute and do that stuff to it.
Yeah, you're right. It was a shock for me too. We think standing on the Earth, you think it's easy to think that the sky is infinite, but actually, it is such a thin layer out there. That little layer of air that's keeping us from the deadly vacuum of space. Well, I'm glad you noticed all these very important things.
My name is Sydney, and I have a question. Can you notice the rotation of the Earth? And if so, how fast does it appear to move?
So, here on the space station, I am orbiting the Earth. I'm going in the same direction as the Earth is rotating. I'm just going quite a lot faster than the Earth. So every hour and a half, I go around the Earth one loop. But once I come back around the world, I'm not over the same place. The Earth has rotated underneath me by, about an hour about a 1/16th of a full rotation. That's how I notice, because after I've done one orbit, I'm not over the same spot. I can tell the Earth has rotated a little bit while I was going around it. That's the only way you can tell, because otherwise it's a very slow appearing movement, very graceful. You can also notice if you look at the stars in the background that they're moving with respect to the Earth, but that's mostly because we on the space station are moving much faster.
Hi, my name is Alice, and my question is that since this year, PI farmers had a hard time getting their potato crops planted and dug up due to extreme weather conditions. So will we ever be able to grow potatoes and other fruits or vegetables in space?
It is very difficult, but we're going to have to. We've actually started. Last month, we grew a couple of plants of lettuce up in the space station, and we just started planting some more. We need to do that because if one day we want to go very far, like back to the moon or further on to Mars, we can't just bring packed food with us. We won't have enough. We're going to have to grow our own food. And if we want to make a colony one day somewhere, we'll also need to learn to grow food. And everything we learn on growing food in space, because it's just as difficult as on Earth, can help the farmers on the ground and difficult places. So I think we have the same challenge, and we'll find solutions together.
Hello, my name is Noah. My question is, could you create static electricity in space? And if not, why?
And yes, you actually can, and it is a problem for space station. It has these giant solar arrays that are, generating electricity from the sun, and we're going very fast over the Earth. It's not in complete vacuum. There's a few little, molecules that we can grab, and so that can create static electricity on the station. So when we go outside wearing our space suits, we have to be very careful. So we deploy little antennas just to protect us against that. But yes, it is possible. But because there's vacuum, there's no air to transmit the electricity. It takes much more static electricity to cause like a lightning bolt, to cause a shock between them. But it's possible.
Hi, I'm Cadence. Why should young people care about the environmental changes you are trying to document with your photos?
I think everybody should care about it, foremost the young people, because this planet is your planet just as ours. It's probably more your planet than ours. One day we'll be gone and it will be yours. And the solutions to all those problems lie in some young people's brains. All these new ideas are in the minds of young people. Your minds are our greatest resource, our greatest hope for the future. So I think all these environmental discoveries we're seeing, yes, they're bad news, but at the same time, they're a good wake-up call, and it's better to start thinking about it earlier than later. So I look forward to the great solutions that are going to come from young people's minds.
My name is Ryan, and have you ever encountered any space junk in your travels?
Hey, Ryan. Fortunately, not seen any big space junk because that would be scary. the space station is going around the world at about 8 kilometers per second, and so is space junk. Space junk is often little debris from other satellites. So if we meet it, it's like, it's very dangerous. It can hurt us. We see station is peppered with tiny little impacts from either piece of space junk, but most likely just little pieces of space dust. We call them micrometeorites. It's everywhere on station, a bit like mosquitoes on the windshield of a car when you're driving on the road. But so far, nothing big has hit us. And that's because people on the ground with radars are tracking all the piece of space junk, several tens of thousands of them. And whenever there's one that's coming close to station, we dodge it. We move station up to kind of hop over it.
Hi, I'm Zeke, and have you ever solved any of Earth's problems being in space?
Hey, Zeke, that's a great question. Space is so difficult and it's so exciting, and it seems to attract, kind of the best of humanity's power to invent and desire to be creative. And so over the decades, the space program has come up with all sorts of solutions to their problems that happen to be also great solutions to Earth problems. A lot of new materials were invented for the space program. A lot of medical discoveries were made for the space program. A lot of robotics technology was made for the space program. So in a way, space is like an excuse to scratch our heads and solve really tough problems. And then, we find that we can apply that on Earth. And that happens all the time.
Hi, I'm Zoe, and I was wondering if going into space changed how you see the Earth.
In many ways, Ellie. First, I knew that the world was one beautiful planet, but it was just images in my mind. Now I see that even with my eyes, and it's really touching because the Earth is so beautiful and graceful, and it's the only thing alive that you can see out the window. Everything else, like the moon, is a dead piece of gray rock. The sun is a big ball of fire. Other planets and stars are just little cold dots. But the Earth is beautiful, it's blue, it's breathing almost. You can see the clouds moving, there's storms somewhere, northern stars. You can see the activity of humans, you can see it at night. So you can tell it is so much more attractive than anything else you can see. So that's one thing that has changed it made it even more endearing to me. Then also, it's made it very obvious that all humans are together, one race, if you want, on one planet. It's as if Earth was the spacecraft of humanity. Here I am in space station, and it's keeping 6 people alive in the vacuum of space. But Earth is keeping billions of people alive, and billions of animals, and billions of plants alive in the deadly vacuum of space. So we are all astronauts, and our main spacecraft is Mother Earth. And finally, it has made it very clear to me that we are responsible to keep Earth in good shape. Because together we scratch our heads and we can find solutions. And when we work together between the nations, instead of going to war, but if we manage to work together, putting our differences aside, we can accomplish miracles and things that we thought were impossible. And I believe that gives me a lot of hope for the future.
Hi, I'm Gabe. Can you see the Great Pacific Garbage Patch from space?
So no, I was not able to see that, and you know why? It's because most of that great garbage patch is very small pieces of plastic, or that are floating. A lot of them just under the surface. So it's not really possible to see them with your eyes from up here. But there's even some satellites have a hard time going through the water to see them. So really, the discovery was made by people who actually went there physically. But seen from here, I was not able to see it.
Hi, my name is Faith, and I was wondering, do the stars, sun, moon, and other planets look different from space than they do on Earth?
Yes, it's a bit surprising. So first, for example, the moon. The moon looks pretty similar in space than it does seen from the Earth, except it doesn't change color like it does on Earth, at sunset or sunrise. The sun looks a bit different, though, because what's surprising is here during the day, the sky is not blue. During the day, the sky is still black, just like at night. And the sun is just like one very, very bright big star, but it's the same color. It looks like another star. What's different is the stars also. Instead of twinkling, they're just like little points, very precise points. They don't twinkle because the twinkling of the stars comes from the atmosphere. On Earth, we look at the stars from the bottom of the atmosphere, and it's the atmosphere that makes the stars twinkle. Here in space, they look kind of cold, if you want, and lifeless, just little bright dots. So things look a bit different from up here.
Hi, my name's Emma, and I was wondering if you can see the coral reef dying from space.
So we can see the coral reef very well, the big ones, like in the Bahamas or in around Australia. We can see the beautiful colors of the oceans in those areas where the ocean is shallow enough for corals to grow. But I was not able to see the bleaching effect from here. We're too far away to see that effect. But there are some specialized satellites who from space study exactly that question to follow the evolution and the health of corals. And it's very important because in a way they're very sensitive. So if a coral is in good health, it means the ocean is in good health. So we got to keep track of them.
Hi, I'm Jack Bryan. What kind of hazards are astronauts exposed to while doing their work?
So there's a couple of dangers we face here. So first, imagine if a piece of space junk or a meteorite or a shooting star hit the space station and make a hole in our spacecraft, then we would lose the air. It would make a leak. And so we would have to quickly close the hatch in that module. The station is built like a submarine. Every little room has very tight doors that we can close to isolate it. That's one potential problem. Another problem is if we have a fire on board. You know, if you have a fire in your home, you just leave your home and then call the fire department. Here we can't. We cannot go outside. We have to fight the fire from inside. So that would be also something we're really well prepared for. And the station is very, very safely built to protect against fire. Another problem could be if the air we breathe becomes toxic or poisoned by some chemical. That would be a problem because we cannot open the windows, of course, and we have to stay here. So we have to live on gas masks until we can clean the air. These are the biggest problems. Other problems you can have, well, there's radiation in space, and so that can affect your genetic code, and maybe if you're not lucky, it can increase your chances of developing a cancer later on in life. These are the biggest problems that we face. Other problems happen, for example, some people, their vision changes and you come back to Earth and you don't see as well just because of the way the fluids in your body move around. But we are looking at ways to minimize that problem. Other things that happen to our bodies are pretty much reversible. Your bones, your muscles, they change in space, but they come back when you're going back to Earth. Your sense of balance, also, even your immune system gets affected, but that also comes back to normal. We're learning a lot about all these problems, and it's going to help us go further into space, but it's also helping everybody on Earth because all those problems that astronauts face, of course, they're problems that anybody can have on Earth for different reasons. So we kind of go hand in hand, the medical research on the ground and medical research in space.
Thanks, David. We got about 1 minute left. We're going to squeeze in one last question here.
Hi, I'm Owen, and I was wondering if the influence of gravity extends out forever.
Yes, it does, but it quickly becomes weaker and weaker and weaker. So, for example, as you get away from the Earth, the gravity of the Earth gets weaker and weaker. Here on Space Station, it's still pretty strong, like 90% of the gravity of Earth. But we're going so fast, we don't feel it. We're kind of falling forward all the time. If you get somewhere near the moon, suddenly the gravity of the moon is as important as the gravity of the Earth. So you stop feeling the gravity of the Earth and you start falling towards the moon. So you kind of go from one source of gravity to the next as you go further and further. But every source of gravity doesn't really stop anywhere. It just gets overtaken by the nearest planet.
David, we know you got a busy day. Thanks for spending a bit of time with us today. We're very grateful for it. You're doing a great job. Keep it up. Look forward to seeing you back on the planet.
Thank you, Jeremy. Thank you, everybody. Great questions. Thanks for taking an interest in our planet. It's our future to all of us. Bye-bye from Space Station.
Sorry we didn't get to your questions, guys.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Canadian Space Agency and participants. Station, we are now resuming operational audio communications.